Okay, so we're going to start today's lesson with talking about adding and subtracting irrational numbers with like denominators. And we're going to go through the steps needed to solve for this, as well as work through about 4 examples to ensure proper understanding. So let's talk about the steps. So when the denominators are already the same, simply add or subtract the numerators. Then we're going to simplify the answer. And by doing so, we're going to factor the numerator. Then we're going to need to factor the denominator if need be. Okay, in which case, if we have them both factored out, the numerator and denominator, then we're able to cancel any common factors. And you'll see how we go about doing this. So the big thing is to simplify if they have the same denominator by adding or subtracting the numerators. And then we're going to do some factoring and canceling out common factors, okay? So let's look at this first problem here. We've got d squared over 2d squared minus 6d minus 9 over 2d squared minus 6d. Okay, so we have the same denominator. So in this case, since we have a minus sign right there in the middle, we can just subtract the numerators and combine those and put those over the same denominator. So let's do that. So now we got 9 squared minus 9 all over 2d squared minus 6d. Now let's go ahead and factor the numerator and denominator out and simplify this down a little bit more by canceling the like factors, okay? So to do this, up top, by using the lessons that we worked over the past week or so with doing on factoring, we can take this top one of d squared minus 9, and that factors out to d plus 3 times d minus 3. And then on the bottom, we can factor out of this monomial set of 4, we can factor out a 2d, because 2d can go into both the 2d squared minus 6d. And as you can see there, we both up top have a d minus 3, and on the denominator, we have a d minus 3, in which case we should be able to cancel those guys out. So once we cancel those out, there's nothing left to simplify, and our answer is what we see right there, which is d plus 3 divided by 2d. All right, let's do another example here. So number 2, we have 3x divided by x squared minus x minus 3 divided by x squared minus x. So we have the same denominator. So now we can just subtract the numerators. So in that case, we have 3x minus 3 divided by x squared minus x. So now we don't need to do any crazy factoring here. It's pretty much just looking at as far as what we've dealt with in the previous lesson as far as the greatest common factor on both of these, okay? And at the top there, you should be able to see we can factor a 3 out. And on the denominator, we should be able to factor an x out easily. In which case, we should get 3 times x minus 1 in parentheses on the numerator, and denominator we should get x times x minus 1. And then, as you can see, x minus 1 is common in the numerator and denominator. So therefore, those can be canceled out. And we are simply left with what we cannot reduce anymore, which is 3 over x. And 3 over x is our solution. Okay, let's do another one. We've got 2x over x squared minus 1 plus 2 divided by x squared minus 1. So again, same denominator, so we need to add the numerator values. So we should get 2x plus 2 over x squared minus 1. Well, up top, we can do the greatest common factor. And then on the bottom, we just need to factor that out into 2 polynomials. Okay, so up top, we can take a 2 out, which would be left with 2 times x plus 1. And on the bottom, you can take that guy and break it into x plus 1 times x minus 1. Okay, so now you should be able to see that the x plus 1s should cancel out. Okay, and With that, disregard that red line on the denominator. That should be over the x plus 1. I apologize. So the x plus 1 should cancel out, and you would be left with the x minus 1 on the bottom. So again, this should give you 2 over x minus 1. Again, disregard that line and denominator on the step prior, because that red line should go over the x plus 1. All right, I went back and fixed it, so therefore it's now good. So the x plus 1's cancel out, so therefore we're left with the answer of 2 over x minus 1. Let's do one more example to finish this up then real quick. So on our last example here, we've got 4x minus 1 over x plus 4 minus 2x minus 9 over x plus 4. So on these top two, let's go ahead and subtract them on the numerators over the same denominator. So if we do that, we get 4x minus 1 minus, in parentheses, 2x minus 9, all over x plus 4. Now it's important to realize that that minus sign is for the entire monomial of 2x minus 9, because that's going to change the sign, the side of that monomial, okay? So if you rewrite that by changing the sign, you should get 4x minus 1 minus 2x plus 9. So that positive 2x turns into a negative, and that negative 9 turns into a positive. Again, that's still over x plus 4. So now let's combine like terms in the numerator. So to do that, we should take 4x and minus 2x, in which case we'd get 2x. And we have a minus 1 plus 9. Well, 9 minus 1 is 8. So we should get 2x plus 8 on the top. All of that is still divided by our x plus 4 because we haven't done anything with our denominator. Now we can factor out a 2 out of the numerator. So we can take a 2 out of there, which we'll be left with 2 times, in parentheses, x plus 4. And now you see we can simplify this even further by reducing that common factor in here. We have x plus 4 in the numerator and denominator. Those guys both cancel out, and we are left with a 2 for the answer. All right, so with that, again, remember, if the same denominator, you combine the numerators and put them over the same denominator value, then you can factor the numerator and denominator if need be and cancel your like terms. All right, so I hope that I walked you through good examples there to get proper understanding, and I'll see you next time.